Hello and welcome to the beginning of Parametric Equations. So, what are parametric equations? And that's the first thing. This explains here what parametric equations are. So here, what we're used to when we look at equations, they're usually written in terms of x and y, or maybe two other variables, but we only really have an equation written between x and y, a and t, and so on. And when we're doing this, it's typical with two variables, x and y. We can relate the two by a single equation, so this is our single equation. This is known as our Cartesian equation. The line shows all the points xy, where xy is a coordinate, which satisfies the Cartesian equation, and there's our graph. However, in mechanics, and can I just say this, though we're talking here about mechanics, this is not just going to be on the mechanics paper, it'd be very much in your core maths syllabus as well. We might want each of the x and y values to be some function of time, as shown in this example. So we've got the x variable, and this is linked to time, and a y variable linked to time. This allows us to express the position of a particle at a time t as a vector. So we now can see how the position, if we're thinking of modelling our particle, would change in terms of time t. These are known as parametric equations because each of x and y are defined in terms of some other variable known as a parameter, in this case t. It won't always be t, it can be other letters. Quite often you see t used, but if it's not t, the methods are exactly the same. So just pause and check that you understand that this is the single equation, whereas here this is two equations for x and y, and they're written in terms of a third variable. So you've got x in terms of t, y in terms of t, however x and y are linked via that variable t. And it's important to remember that's what parametric equations are, and that's why they're actually quite helpful for us and why we need them. So here's an example. A curve has the parameter equations x equals the natural log of t add 3 and y equals 1 over t add 5. Find a Cartesian equation of the curve of the form y equals f of x, where x is greater than k and k is a constant to be found. So first of all, when it's asked you to find a Cartesian equation, what it's actually asking you to do is just rearrange. It's just practicing your rearranging skills. It sounds something quite grand, but what it's asking you to do is to write an equation in terms of x and y and not have t in it. Now, with any question, there are going to be a number of ways of doing this, and one way will work really easily and other ways won't be so efficient. And I want to show you this here because it is a skill to learn which method to use. And how do I know? How does anybody know? Practice. It's like quadratic equations. When you first factorise quadratics, it can be quite hard to know how to factorise them because there are different ways. Do you put the negative here, the positive there? What numbers are you going to put in? And then you just get that feel and you just know. And then trying to explain to someone how you know is quite complicated. And this is the same thing. You're going to just have to by practicing, get that feel. So I'm going to deliberately do it the more complicated way to start with. So we're going to eliminate t from this, and I'm going to start by saying, well, I've got y equals 1 over t add 5. So I can rearrange that and write this. Okay, and then I can say, well, that means that t add 5 equals 1 over y. So t equals 1 over y, subtract 5. So I've now found a way of expressing t in terms of y. I'm going to take this here and I'm going to substitute it into x. So instead of putting the t in there, I'm going to put 1 over y, take 5 in here. So that's going to be my next stage. So scrolling up a little bit, I would write x equals the natural log of t add 3, and therefore x equals the natural log of 1 over y, subtract 5, add 3. So x equals, so I've now, if you notice at this point here, I've actually got a Cartesian equation because I have now written an equation that hasn't got t in it, so it's now a Cartesian equation. So when it says those two equations with t as the third variable, it's parametric. At this stage here, I've now eliminated t from the equation by substitution. A bit like you could do also in simultaneous equations. And now I have that Cartesian equation, but I need to tidy it up because this isn't the most simplified form. So here I then could write ln, let's turn that to blue, the natural log of 1 over y, subtract 2. Now that is the Cartesian equation, but if you remember back to the beginning, it does ask for it in the form y equals f of x. So if I left it like that, that's not the format that I've been requested. So here I go on and I'm now going to have to say, well, this would be then e to the x equals 1 over y, subtract 2, and then I'm going to say that's e to the x, add 2 equals 1 over y, and because I want to get y equals, I then would write that. And that's my Cartesian equation. Now, that is one way of doing it. That's absolutely perfect. You would get full marks, but sometimes you will find if you choose the wrong way to attack the question or do the question, you will hit a bit of a dead end because you'll end up unable to manipulate it particularly easily. So yes, that one does work the other way, but you can see there's quite a lot of workings. So what is the other way? Well, let's go back to the beginning. And here, I'm actually going to start with the x. Like that. This I can then write as e to the x equals t add 3. And then from here, I can say that t equals e to the x subtract 3. So there is my equation where t is the subject of the formula and you've got on the other side an expression in terms of x. So then I'm going to substitute that into y. So here's y. And now I've just substituted in here, instead of the t, I've put my e to the x subtract 3, and that becomes y equals 1 over e to the x add 2, which is exactly the same answer, but I had a lot less stages to get there. And it's what I really need you to gain from this is have a go one way. Don't be concerned about stopping and trying something different. And you might have to do that 2 or 3 times. This is an easier example. You can't just keep thinking, if I keep going one way, I'm going to get to the answer. It's always worth leave what you've written down on the page, then have a go at something else. But make sure you obviously choose when you get to the end which way you're going with, so the examiner clearly sees. Now we have got the Cartesian equation, which is really, really good, but we do need to go back and just check we fully have answered the question. Always should do that. So here, find a Cartesian equation, yes, of the curve of the form y equals f of x, where x is greater than k and k is a constant to be found. So I need to write down about my domain, because this is a domain. It's what x is. X has got to be greater than a particular value, and you need to find that. Well, from the question, I can see that I have this, that t has got to be greater than -2. So if I just go over here, if t has got to be greater than -2, then putting that information into x equals the natural log of t add 2, which is our equation linking x and t. That should be a 3, by the way. Just check that question over here, do you see? If I put -2 in, I know it's got to be greater than -2, but let's put -2 in. You would find that x equals the natural log of 1. And the natural log of 1, you should know, is 0, because that's really important that you firmly get that into your head later when we do integration. So the natural log of 1 is 0. So therefore, it could be possible that x might be greater than 0, but we need to just think that through. So we know this is our function, and I need you to think a little bit about the graph, because if you think of our graph of the natural log, if I was just trying to draw the graph of y equals ln of x, it would be like that. Now this is just a transformation of that graph. So what it means though is as t increases, even if I transform this graph, as t increases, then this here increases. I should have perhaps put a t there rather than an x. That would be better to help you. And that should be, let me just erase that to make it a little bit clearer for you. I'm going to rewrite this as x equals ln of t. So what we're getting at here is that as t increases, x increases. Okay? So therefore, from here, we can say that, yes, if we're starting at x is greater than 0, it's going to continue to increase. So my domain for this question will be also x is greater than 0. So that is my final answer, would include all of that. Okay? So that there is finding a Cartesian equation of a curve and including the domain. And remember, the domain are the input values, the x values in this case. Okay, so now we're going to go and look at part B, which asks us to find the range. So write down the range of f of x. And remember that's saying, well, if x has got to be greater than 0, that's my domain, what are going to be, so there, if you think of a function machine, they're the values coming in. What are my range, what are my output values? So I'm going to need to know that t is greater than, so this, I'm just going to actually write part B here because I think that would be worth doing. So this is part B. T is greater than -2. And I also know from the question that I have T, y equals 1 over T add 5. Now let's think about this. What happens when T is -2? Let's look at when T equals -2, what is the value of y? Because it gives us an idea of what's happening. So I get y as 1/3. Now let's think about what happens. So as T increases, so here I'm going to have T increasing, that would mean that what I'm dividing by increases. So the bottom bit, so the denominator increases. Now, as you know, so if T is increasing and my denominator's increasing, if my denominator's increasing, therefore y, because it's 1 over, will be decreasing. So y will decrease. Because as your numerator gets bigger, as your denominator gets bigger, if your numerator stays the same in your fraction, then the fraction is getting smaller and smaller. So therefore, y, the range, which you write as f of x, is y is less than 1/3. And remember, it's less than because if I go back up to the original question, this was here greater than -2, and it's that decides the inequality sign here. And that's your answer for the range. And that's that question finished. So that's, I wouldn't say it's the whole question, though I've said I know a little while ago it's easy. It is one without trigonometry, which sometimes people find hard. It's not the easiest you could get on a paper, but it's sort of middle. Now let's look at one where we have trigonometry involved. So here we now have some trigonometric functions involved. So a curve has the parametric sequences x equals sine t plus 2 and y equals cos t subtract 3, where t is a member of the set of real numbers. A, find a Cartesian equation for the curve. So here I've got to somehow eliminate t. If I rearrange this, which is where some people end up going, not a good idea by the way, you could end up, if I take the x, you could write this, and then you're going to end up with t is sine to the -1 of x minus 2. Personally, I'm then going to tell you I'm not going to carry on from there because that is too complicated. So that is out. The same would happen, by the way, if I do it with this one here. So here we've got to think of a way of eliminating t, but we've got a sine t and a cos t. What you need to remember is that you know this. And we learnt this in AS. So sine squared t add cos squared t equals 1. So if I now rearrange both of these, I could write x subtract 2 equals sine t and y add 3 equals cos t. So they are my two rearranged functions, which I then can substitute into my trigonometric identity. So instead of sine squared t, I'm going to write that. and cos squared t would be that, and this here is 1. So here, what do you recognise that as? I'm hoping you're going to say it's a circle. And the circle would have centre to -3, and it would have a radius of 1. So you have that there is your Cartesian equation. And now, where it says sketch the curve, it's going to be like that. This here is going to be 2. That there is going to be -3. And you could, if you wanted, put on that, it's going to be 1, and that there would be 3. So its centre to -3, and its radius is equal to 1, because the square root of 1 is 1. So looks not particularly nice to start with. I don't disagree, but actually beautiful how it works out. I mean, you've managed to turn that there, 2 parametrics, into a lovely circle. So you've managed to link time in if you needed to. Let's have a go at another one. So here we've got sine t equals sine 2t. Now I include this here because according to which order you taught the syllabus in, you may not have learnt about double angle fully yet. But I'm going to tell you that if you have sine 2a, that equals 2 sine a cos a. So that is a link between, it's another trigonometric identity that you will learn. So if you haven't learnt it already, you will learn that. Just like you've learned sine squared x plus cos squared x equals 1. This here is one you will learn that links double angle identities. So if we just accept that in case you haven't learnt it yet, when we look to find our Cartesian equation, this might be relevant because here I've got x equals sine t and y equals sine 2t. So y equals sine 2t, and using the identity, that's the same as 2 sine t cos t. And in here, I know from looking back at the question, sine t is the same as x. So I can write this as 2x cos t. But then if I'm honest, I've got a bit stuck. And sometimes you have to just have a bit of a go, write something down, see where you end up. So I'm going to now go, well, I know that sine squared t plus cos squared t equals 1. So again, trying a different, so that was me trying one idea. Here's another idea. I can say that sine squared t, well, that would be x squared plus cos squared t equals 1. So actually from here, interestingly, I could get this, which actually would mean that cos t would equal the square root of 1 take x squared. Or I could write that in many other formats with the power of a half, whichever you prefer. Now, interestingly, I've now got this. I could use this and this together. And it is that thing of when you have a go at these, have a go. If you get somewhere, underline it. And the reason I say underline it is so that you can find it later. Go, oh yeah, I've used that. I found that up there. Because when you've got a whole pile of workings, keep going back and finding something that's important is quite difficult. So y equals 2x square root of 1 minus x squared. And that there is a Cartesian equation. May not look very nice, and that's the benefit of parametric. They do allow us to write it in a better format sometimes, something that looks simpler and something we can work with. And by the way, it will become even more useful as you move through maths. This is just the beginning of it. So there is our Cartesian equation. Now, have we answered the question fully? No. Because you've got to write it in that form, yes, and then I need to find my domain. So I'm going to need to look at my values here for t, negative pi over 2 and pi over 2. So I think I might go over here. So when t is negative pi over 2, x is equal to the sine of negative pi over 2, which equals negative 1. And when t is pi over 2, x, because we're looking at the domain, that's why we're putting it into x, is 1. So what is the domain? Well, the domain is going to be like that. And what we need also to be aware of when we're doing it is that and that go together. Okay, so and the value for k is 1 in both cases, because notice this is negative 1 here and this is 1 here, and that's why k has the same value, because they've put the negative sign in for you. So they've actually helped you get that domain. They've given you a lot of information. Do keep going back to that question. That's a real important exam skill. So now we need to find the range. Remember, the range we're going to be looking at here and what happens to the t values here. So our range, whoops, this is B, not C. The range would be the sine, let's put t equals negative pi over 2. So it'd be the sine so y would equal the sine, and it's, remember, it's 2 lots of that. So when you put that value in, that would be negative 1. And when you've got t equals pi over 2, again you've got to multiply it by 2 because it's 2t. Which is 1. And hopefully I can manage to squeeze in this last bit. Don't know whether I will. So I've written too large, but t, oops, not t. So I'm now doing my, the range for f of x. You may and I've also got 1. Okay, now I'm just going to pause here with range and domain. Make sure you know when you're using f of x and y. It's because that's quite important. You can use y here, but because you are talking about y, but because they've said the range of f of x in the question, I'm writing f of x, because if they've said f of x, that is what I'm going to use, and I get that clue from the question. And that last one I think is the most challenging, and particularly challenging if you haven't yet, which some of you may not have covered that, but don't worry if you haven't covered that yet. because you can just use it as an identity.